Hello everyone. So today, uh, first, hello everyone. So welcome to my channel, Cloud and Data with Kaushik. Sorry for network, some network issue are there. And so today we are going to discuss that how we can create different charts on top of the iris dataset. We already shown that how we can create that, predict the optimal number of clusters, and this demo is dedicatedly for we can create different charts on top of the iris dataset, right? And environment in this time I taken Google Cloud because previous demo I shown in that Anaconda Cloud, and this demo I take in a Google Cloud. Okay, so without any delay, let's get started. So I am inside my Google Cloud environment. You can see this is the Google Cloud interface, right? And this is the cell. And here code and other option is text. So if you want to add some code here, any title or any comments or heading, you can use the text comment. And code for that you can use the cell comment. Okay. So write text. You can also up, and also you can change the position of this. There is no issue, you can change the position. So some points that I hope we should have known before going to start coding part in Google Cloud. So you can see the Google Cloud, it is my folder where my Google collaboratory Google Colab file is there, right? And you can see this is my file, IPYNB file, right? So, and this is the connect option. So connect a new runtime. That means what? If I want to run, if you want to add some comments over here, okay, I can add one comment and I can execute the same. So this is the front end, right? Front face. But behind that same, behind the background, something is happened, right? And where it is happened, that is taken care by Google Cloud or GCP. You no need to worry about the servers. Okay, it's a managed service and behind the scenes something is happening, right? So you no need to worry about the servers. So processing and the execution part is happening behind the scenes. Okay, so that is the reason you have to connect a new runtime. So my interface is ready, my cell is ready, but I have to connect the servers, and this is the behind the scenes. So that is called the managed service. Okay, we no need to worry about something because we just write the code and execute the cell. But something is happening behind the scene, right? So first we have to connect. You can see it's showing the connecting, and that means something is connecting with this interface. So some VM or virtual server, virtual machine is there that has to be connected with that. And you can see connected. And green tick mark is there, right? You can see focus the last run frame. So you can see the RAM disk that is being available. And I just hover in the RAM and disk. What is showing? Connected to Python 3 Google Compute Engine, right? The backend, where the requests are going and executing, right? That is my Google Compute Engine to GCP, because Google Colab is product of GCP or Google. Okay. And how much RAM is used? RAM is actually 10.72 GB, and that has been the total RAM size, and 26.89 GB for the provisioning purpose and other purpose that has been used. Okay, and the disk size also be there. So now my front end is connected to my server back end, right? And now if I run some code, then it will only be executed. But before that, connect with the runtime. Yeah. So you have to understood this concept, and you can also just click over here, and you can also see the resources, right? So resources is system RAM and disk that has been provided. So who has been provided this thing? That is provided by the GCP Google Cloud in the backend part, right? So we no need to worry about this. They repeatedly told this concept. So we know that I can write the code, but where it's going to be executed? That is the resources section, right? You currently have 0 compute units available. And resources offered free resource, but not guaranteed. So they are providing some suggestion that you have to add purchase more unit if you available. But my demo is not that much bigger with the data set, right? We no need to add the resources. And you can also change your runtime, just click over there. By default, runtime is my Python 3. Either you can take R or Python 3. So I take the runtime that is Python 3, okay? And hardware accelerator, you can just click for getting the information for the hardware accelerator. So it's just CPU, TPU, T4 GPU, right? By default CPU I am providing. And for the large computational data set or massive data set, if you want to compute like deep learning project, any kind of bigger data set, then you can use the TPU or T4 GPU as per the use case. But for the small use case, na, you can use the CPU, okay? You can save the hardware accelerator part. And then you also view your resources that I already told one part and connect to a host runtime that is there. Like you can also click that your connect to hosted runtime. So it's already connected. So again, I'm going to connect and initialize. You can say connected. Okay, same thing. One more option that is you can share your work with the different means you can share publicly, you can share your organization, so you can add your people, you can add your groups, so you can share your job or you can share your work, okay? And you can see the general access, anyone with the link. So this link, anyone with the link, that means publicly open, anyone can access this link and anyone can see your work. And restricted means that if you have restricted some organization, so otherwise nobody can access this link. So that is the meaning of this thing. General access that has been divided in restricted and anyone with the link. You can add your people. So they have add some kind of people's name. So you can add over there. Okay. So and you also directly copy the link and you can share. Whatever you can call comfort. So you can do that. As of now, I am not doing anything. Okay. So first, what I'm going to do. So this is my some concept of Google GCP or your Google Colab Lab. Okay, and this is the toggle button. You can see. Just click. 1 minute. One is the button. Anyway, we can show this thing later. So it's a toggle header. That means my header is currently hide, so you can hide or show in this case. Okay. Now, one more thing that this is the place where you can store your data, you can store your files. Okay? And you can see this is the place where you can, like, by default it is collapse mode. So you can click and you can upload your files, upload your CSV files, text file, anything. You can, it's a storage option basically, and it's a session storage. Okay. So with that, if my session is done, that files and folders will be gone. So we cannot get back this file. So this is a session storage kind of things. Okay. I hope you can understand, and you can, for option also be there. You can mount your drive. That means you can that Google Drive you can mount with that Google Colab, and then you can access the files and folder from that different files. So that can be your unique solution. So I can say this is that cannot be used as a session storage. Okay, if you mount it, otherwise the this file can be in session storage. Any any files you can add or any folders you can add, then up to or when the session has been done, so that will not be available. And this is the one option. So you can see hide hidden file. So dot config, that is one by default hidden file that is showing over here. Any configuration kind of things that has been stored over here. So by default this is hide, and you can upload to sessions today. Just click over here and you can upload anything over from these things. Okay. So this is 4 or 5 that icons and some operations are there. Okay. Let's focus on my work. So just I adding this thing only because you can be familiar with the Google Colab basic operations and some kind of functionality. So you will be working with a great means concept, right? On a good concept, right? And you can also comment. You can see you can add your comment. So as per the sale, you can write your comment and you can share your comment. Okay. So now we can let's start. So in this demo, we are going to understand the different chart. Different chart we are going to create in this demo. Okay. So first, what we have to do, we have to import the libraries, and these things I have to just copy from my my Jupyter lab from that Honda Anaconda Google Cloud. Okay, Anaconda Cloud. I'm taking these things because that thing already done. I just copy and then add over here. Just a minute, it will takes some time. My already be there, so you can just copy these things. And on the previous session, I already shown how we can create all the things, right? You can just add and just write over here. And here you can write, instead of writing as a comment, you can just cut this thing and you can paste. Okay? And press, you can see here you can run the cell, or shortcut is Control plus Enter. Okay, just press Control plus Enter, and your libraries are adding, and your data set also be there, right? And one more libraries that I'm going to add. Apart from that, just I'm going to add over here. So you have to import C1 as essence. Okay. This is also one data visualization library. Okay. You can see. Just a minute, it is loading, and that is also data visualization library. You can see on top of that matplotlib. So C1 is, you can say, is a statistical data visualization library based on matplotlib. Okay, so it provides an interface for creating information and attractive statistical graphics. Okay, so that is the reason I am using this C1 library. And the features, you can see, you can use the statistical plots. So you just write over here. I just create one note. You can create one file. Just notes.txt. You can write these things. Just click, and I just write this one or two liner note, so you can refer further. C1 is a statistical data visualization library in Python, which is based on matplotlib. Okay, and it provides the interface for creating information and attractive statistical graphics. Statistical is statistical graphics. You can write these things. Okay, so this is the C1. That is the reason I'm using the C1. Okay. Now, one more thing that I'm going to add. So this is my note, and then you have to input the data set. So we have to import the C1 matplotlib from sklearn. We have to import uh, like directly you can import sklearn.datasets, and you can import your IS dataset. So my all necessary libraries that I'm going to add over here. Next task is that you have to load the IDs data. This is the library, and you have to just take one code. You have to click the code. Just use that thing. And Now you have to take one cell and you have to load the iris data. So I'm adding the comment over here. To load the iris data set. Okay, you can load the iris data set over here. Just spelling. Yes. So I have to load the iris data set. So my all libraries I have imported and just write data is equal to load iris. Okay, and you have to just invoke or initialize this. You have to import the class from this library and just take the first initialization, right? Data is equal to load ID. So everything will be there. And just create one data frame is equal to SNS dot load. You can see load data set. So on top of the SNS, I'm going to load my data set, and this data set name obviously be iris. Okay, just press Ctrl plus Enter, and load iris is not defined. Okay, I'm not actually run this cell. Okay, just run this cell. Yes, now I have to run this cell again. So my iris data frame, you can see, I can just write the code or take one cell and iris underscore df dot head if you write, and only two rows you want to see. So you can see this is and you can see that only with the data frame my iris data is loaded on top of the SNS, right? We are just going to load my iris, load the data set from the SNS, and this is the iris. And one more interesting thing, that suggestion of charts, right? If you click over here, na, so automatically you can see there are different charts distribution with every they have been suggested, right? I am not going to create this thing. I just click on the suggested charts and it will show automatically. Okay, so this is very awesome thing. Okay, so you have to know this thing. Just click over here and the suggested chart they have given as per the distribution, right? So like you can see the distribution, 2D distribution, time series, their values, different charts they have given. They have suggested. So they can understand it's kind of AI kind of thing. So they can predict as per the data set how which type of chart should be there, right? So they have added. I am not going to touch this thing. So my iris dataset is loaded on top of the SNS. Okay, take one cell and first you have to create the scatter plot. And scatter plot, what is the main features, or you can see that I'm writing the note. Scatter plot requires two numerical data set, right? So ScatterPlot requires, or we can apply when, like when I have, I want to visualize, I want to visualize if before going to implement any chart or plot, you have to know the intuition behind that. So when we are going to incorporate the scatter plot, so scatter plot we are going to incorporate when I want to visualize the relationship between two continuous variables, and that is the time we are going to incorporate the scatter plot. It helps to understand the pattern of data points, because they have to understand the data points. There are different columns and different data points are there, right? And try to identify any trends or any patterns that is exist in this data set. Okay, in this data set. And just few points. It is useful when identify relationship and two continuous variable, right? Identify relationship and detecting outliers, that can be positive, that can be negative outliers, okay? And visualizing the cluster. That means if there are distinct groups, cluster means groups of data, right? Group or cluster within, like k-mean cluster we have applied. So this is a cluster grouping of data, right? So visualizing the cluster, we already applied this thing. If there are distinct groups or cluster within your data set, a scatter plot can reveal this pattern. This pattern. You can assume this thing. You can add this thing. So I hope you can understood when I am going to add the scatter plot. Okay, when I'm going to use the scatter plot chart. So just I'm revise this thing. So scatter plot requires what we can apply when I want to visualize the relationship between two continuous variables. And it helps to understand the pattern of data points and try to identify any trends or patterns that is exist in the current data set. Okay, if that is, then by whom we are going to represent in front of the users, scatter plot. Identify the relationship, detecting your outliers, and visualizing the clusters. So if there is any group of clusters, distinct group or clusters is present within your data set, then scatter plot is the ideal choice, or scatter plot can reveal this pattern, right? And Last point, you can add examine correlation. Okay. So this is the thing. Now I am going to use the scatter plot chart. Just go and take one cell and write scatter plot. Scatter plot chart. Scatter plot. Okay. So write SNS dot scatter plot. Okay. X is equal to sepal length. So I have to take the columns, right? So write iris underscore df dot columns. So this is my columns, which I'm going to use over there. Okay? Yes. So copy the sepal length and it should be the x-axis and comma y is equal to your sepal width. Okay, you can write and that is your basis. So you have to take this thing. And next you have to supply your data. Data from your iris BF data frame. Okay, that you have to supply the iris data. Once it is done, you can write plt dot show. Okay, and just click on the cell, and you can see different Setosa, versicolor, virginica. These are from this scatter plot, right? And the grouping they have created. Identify the grouping, right? So they have created these things. Okay. Sepal width and sepal length. X is sepal length and Y is sepal width. Okay. And you can add the title. You write plt dot title, and you can add scatter plot of sepal length versus sepal width. And press Ctrl Enter again, so you can see one titles are there. Okay, so this is the scatter plot chart. First scatter plot. Okay, next is that we have to create pair plot. Pair plot. So go to text, note, write pair plot. Pair plot. Okay. So it will display pair-wise relationship. Pair means one pair and pair-wise relationship between features. Okay. So pair plot is used for display the pair-wise relationship between features. So that is the reason I am going to use a pair plot. So this is another kind of chart, pair plot. Okay. just write the code. Very simple thing. Write SNS. And why I'm going to use this SNS? Because it's used for statistical distribution, statistical visualization, right? With the statistical kind data set, right? So you can, I also written this thing. You can see C1 is a statistical data visualization library in Python, which is based on Matplotlib. It provides the interface for creating information and attractive statistical graphics. Okay. So that is the reason all the data points that I'm going to plot via stat C1 or SNS, like SNS.PairPlot. You have to supply the data, iris df. Why I'm going to create the df? Because you have to supply the data point in each and every charts or data plot, right? So if I only provide the input the iris, no, it cannot be interfered. It cannot be working over there because every chart wants a data frame kind of object. That is the reason I have created the data frame on top of the iris dataset with the help of SNS.load dataset. Okay. I hope you can understood. So iris df and hue is and just write plt dot show. Okay, and press Ctrl Enter or click the same. It will take some time because it has calculating the pairwise distribution, right? And you can see there are different pairwise distribution they are showing, right? So sepal with how many types of histogram, scattered plot, this kind of charts they have given. Okay, so this is the use case of your sepal, sorry, pair plot. You can just zoom in or also zoom out these things. You know, my mouse is not working properly. That is the reason it's disturbing this view. Okay. So this is the pair plot, and you can also write the PLT dot right here, like pair plot of iris data set, comma y is equal to 1.0. Okay, and just please control enter again. And the title is there. This is one kind of chart of pair plot. This is the scatter plot. Okay. Next, take one take. So all because mainly it's a numerical data set, right? So that is the reason we have to create. You can also check the data types. Iris underscore df dot d types. Okay. Oh, sorry. It's take the code and most of the things float, and object. Okay. So this is the data type. You can understand the D types on top of your ID's data frame. So it has given. You can write the print and also print the columns name IDs iris underscore tf dot columns. Okay, let's see. And is there any, how many rows and columns are present? So write save. So 150 rows and 5 columns are present. 1, 2, 3, 4, and 5. 150 rows. This is the last 150, comma 5. That means 150 rows and 5 columns are present. So each and everything you have to know, right? We cannot write only coding in the data science part. We have to know, we have to understand the concept behind that. Okay. So that is the reason I am adding and I am describing this thing. Now what I have to do? BoxPlot. So just write over here. Just click the notes. Write BoxPlot. So the distribution of a single feature or comparison between features. So where I'm going to use the box plot, when we have to show the distribution of a single feature. Okay. And that is the reason I'm going to use the box plot. And we also called it box and whisker plot. Another name, okay? It's also called the whisker plot, okay? And it is used to visualize the distribution and statistical summary of a continuous variable. Okay? And also box plot is show the distribution of a single feature, or you can compare between different features, right? Now I am going to take the incorporate the chart like box plot. You just write box plot. Take the code. Just write SNS dot box plot box plot, and you have to provide this is the x-axis and y-axis. You have to add the petal length and you have to pass your data iris underscore pm, and then write plt dot show. Press Ctrl Enter. Now you can see the box plot is ready. Okay, and these the outliers, this kind of in box format. Okay, in the box format it is coming. So Setosa, versicolor species and virginica, and the petal length is there. So you have to incorporate the box plot and show the distribution of single feature and compare between other features. Okay, and also you can write or you can add the title. You can see right different in the box plot and in the box this kind of outlets is there and this is inside the box how much the difference and distance between the outlets part. Okay, and that is the reason we are using the box plot. Okay, and you can add the title box plot of petal length by species. Okay, so this is one term that I'm going to add. Means you can in the petal length wise box plot I am going to incorporate. Okay, next chart, and if you have any other kind of information, so you can also add. Just I'm going to add all the charts information so you can also understand, right? So next we have the violin plot. Violin plot. So just write a statement violin plot. It's combine the aspect of box plot and kernel density estimation. We are not going to discuss the kernel density estimation, right? So you have to just know it's a combination of box plot and kernel density estimation. Yes, yes. So okay, I am also feeling the concept. So KDF or kernel density estimation is a non-parametric way. I'm not going to add the parameters. Non-parametric way to estimate the probability density. That is a different use case, and there is a different discussion. Density, just you have to know these things. It's a non-parametric way to estimate the probability density function or PDF. Okay, of a random variable. Okay, just you have to know these things. So it's a combination of combine the aspect of box plot and kernel density estimation. Okay, and what is KDA, PDF? That is totally different discussion on the statistical part. I'm not going to add these things. Just you have to know. As per your understanding, just I am discuss this thing. We have the differentiation for that, so you have to understand. So just write SNS dot ViolinPlot. Okay, and you have to pass spaces and see that is your petal length, and just add the data set, that is iris underscore df, and just write plt dot, and you can see uh, just like a violin, right? That violin, the shape is like a just violin kind of shape, right? In singer can use this violin kind of thing, so that is the same shape of this plot. Okay, so it's just totally statistical distribution graphics information. That is the reason I am using the SNS. Again, I am telling these things, and if SNS is working on top based on the matplotlib, and that is the reason I also use the plt dot show. It is working. I created the chart with the help of SNS, but I'm showing the plot by the help of matplotlib. So both are interpret each other. Okay, so it is required for statistical part and it is required for distribution. So both are required. Is a state-based interface to matplotlib. It provides an implicit MATLAB-like way of plotting. So MATLAB is different features, or you can see different softwares that you can use the MATLAB. It also opens figures on your screen and acts as a figure GUI manager. So what is the PLT that is showing, right? It's a module. It's a module, and every information, guys, you can get over there. Every information you can got over there. Okay. Just hover on this PLT and you can get the information, right? Now you can add PLT dot title. You can add the title so anyone can understand. Violin plot of petal length by spaces. Okay, just press Ctrl Enter and the headings are coming. Next chart, click on text. This apologies for that my keyboard not working properly. Okay, so just taking one text, and next is histogram. Histogram. So it's very popular histogram, and we all know what is the histogram is required. Why we can use the histogram? Understanding your data distribution, like histogram provides a way to see how your values are distributed across different range or bins. So bell curves, right? Mainly it will create one bell curves and it will swing the distribution package, right? And they give an overview of the same statistical concept are coming. Central tendency, spread, mean, of median, anything, everything is coming. And same of the data set, right? So I just write the note of one or two liner. Otherwise, write histogram. It is just right. It is also it is useful when or useful for understanding the data distribution. Okay, identify the patterns or what is that distribution. So right, it provide right. Okay, I, it provides a way to see how the values are distributed across different range or different bins. Okay, it, I'm writing here. Best part is that I can write over here. So writing. Or I will conclude the session over here, and the next session I will start from here. Okay. So I have some kind of keyboards kind of problem that I have to solve, and then I'll continue this session. Okay. So I hope you can understood up to these three or four charts, right? Histogram I will start with the next session. So that will be easier for me because I have some problem in my keyboard, so I cannot continue. Sorry for the inconvenience, and I hope you can enjoy the session. You can learn something, and if you like, then please subscribe my channel so we can learn and grow together. And so please subscribe my channel. It will also boost my confidence that is required from your side. And thank you for joining the session. Thank you. Bye.